Everybody. Hope you guys are doing well. So today we will be starting our journey in TypeScript, and we will try to understand um like why to use TypeScript and what advantages does TypeScript give over JavaScript. A TypeScript is basically a free and open source programming language that is developed by Microsoft. A TypeScript is statistically typed superset of JavaScript that adds optional static typing to the language. It is designed for large scale application development, offering features such as interfaces, classes, enums, and models to help developers write more robust and maintainable code. A TypeScript is a superset of JavaScript, which means that anything that you can do in JavaScript is also a valid TypeScript code. A TypeScript code gets transpiled into JavaScript, and the resulting JavaScript code is what actually runs in the browser or other environments. Let's see what he's talking about. So today we are going to start with okay. So TypeScript is basically a superset, right? So what he's trying to say is, if this is JavaScript and anything written in JavaScript, it's a superset, right? So that means if this is it's not a subset, a superset, right? So basically, if this is TypeScript, then the same can be inferred for JavaScript, right? That I mean, if this is so anything in JavaScript will be TypeScript, right? JavaScript is a dynamically typed language, right? So what happens there is no mentioning of types, right? And because of that, at times JavaScript does implicit type casting, right? Because of which the result may change, right? We might not get the desired result that we want. So then, to avoid this, we use something called as static typing, or basically TypeScript, right? Basically, when you add types to JavaScript, it is nothing but can be inferred as if I add type to JavaScript, then it is called as um, so adding type to JS is called as TypeScript, right? So basically, ultimately, so the browser can understand only three things, right? If you think in perspective of a browser, so this is our browser window, right? So it can understand only three things. First is HTML. Okay. Next thing it can understand is CSS. And the third thing that can understand is nothing but JavaScript. So if it is any other language that you are trying to use in the browser, you will not able to use, right? So you will have to convert them into one of the three forms, and then only will you be able to use it. So what happens is TypeScript relently gets converted to JavaScript, right? So this is how that inherent conversion happens, right? We'll see how that happens. Now let us think about some history, right? It is developed by Microsoft. So let's look at some few points about TypeScript, right? So it is developed by Microsoft. and then it is open source, so it is free and open source. uh, it is free and open source. That means there is no licensing to use it, and it is a programming language that is developed by Microsoft. So now the other is basically not what it does is JavaScript is dynamically typed, meaning variable types are determined at runtime, right? This can lead to runtime errors that might be difficult to catch. So TypeScript introduces static typing, all allowing developers to specify types for variables, functions, parameters, and return values. So basically, yeah, as I said, JavaScript is dynamically typed, right? So what it does is it kind of introduces, because of which everything is checked at runtime. Suppose, and it kind of does implicit type conversion, right? Which may change the result. But then what TypeScript does is it adds TypeScript adds type checking on top of JavaScript, right? Thereby now everything is become compile time. So now type checking is compile time. The thing is we are not wasting the processor time, right? Whatever. So that is what happens, right? So till the point to get an error, all the code is run in JavaScript, unlike as there is no compile time checking, right? So now JavaScript, yeah, one of so this basically adds to an issue, right? Since types is not what JavaScript is meant for, like this kind of adds bugs to the code, right? And maintaining that code becomes difficult. So TypeScript reduces that uh, issue as well. Okay, now let's see how do we install TypeScript, and how are we going to work. So remember, first thing that we need to have installed is, now since ultimately my okay, so let's say software needed. Okay, so first thing that we need to understand is we are just running, ultimately TypeScript is getting converted to uh, at the end we are converting TypeScript to JavaScript, right? So basically we need something um, to run JavaScript out of the browser. So for that we are going to use Node.js as our runtime environment, and then the next thing that we need to do is, so first is Node.js, because we need to run JavaScript out of the browser. Now then we need to add the layer for TypeScript, right? So we need to add this layer. Now running TypeScript application. Okay, now Node.js, and okay, so when you install Node.js, your Node package manager is also installed with it, so you can write no, yeah, Node package manager is also installed. This is inherently which is happening, right? We do not need to worry about this. The moment we have Node.js, we also get uh, um, we also install npm, right? Because those two are bundled together when you install them. The first thing, we have got our environment ready to run JS. That is our Node.js. Now why Node.js? Because we are going to run JS out of the browser. If you are running in browser, then you don't need this option. But if you need to run, then you need this engine. Okay. Then we need to add the layer of TypeScript. And when we install Node.js, the Node package manager is also installed. Let's go to Node repository. So Node Node repository, or it's called as npm repository. Now let's search for TypeScript. Okay, so this is okay. This is the official web page. You can go here. Now, TypeScript is JavaScript with syntax for types. Now, TypeScript adds additional syntax to JavaScript to support a tighter integration. Now, okay, and TypeScript understands JavaScript, uses type inference to give you great tooling without addition. Now, okay, now who is maintaining this repository? So it was last published 9 hours ago. Okay, let's see. There will be, okay, the company who manages this is managed by Microsoft, right? But I'm not able to. Yeah, published recently, published 19 days ago. Okay, so now let's see what does npm or node package manager will do. Okay, so now we need, okay, now TypeScript is present in our npm repository. So basically, this is a repository where you can publish your own packages in JavaScript, and then you can host them. Now the advantages of doing this is it kind of makes those packages available to all, and anyone can install it using a terminal and some command line interface or a terminal. And then, so basically TypeScript is present in our npm repository. Now we need to install it on our development machine, right? So here you go, TypeScript maintained by, so there is, if you see the package, and then it is like it is mentioned here. Okay, so this project has been adopted by the Microsoft Open Code of Conduct, and if you want to read the documentation, you can. So this is how TypeScript is going to work. Now, okay, this is the official page for TypeScript, right? So now we are on, this is basically TypeScript homepage. Now, okay, now you can see docs. So basically you can see the different ways or declarations. Then you can see resources like how JS to TS conversion. A TypeScript stance is an unusual relationship to JavaScript, offers all JavaScript features and an additional layer on top of this TypeScript's type system. For example, JavaScript provides primitives like string and number, but it doesn't check that consistency is assigned there. TypeScript will do. This means that existing JavaScript code is also TypeScript code. The main benefit of TypeScript is it can highlight unexpected behavior in a code, lowering the chance of bugs. Okay, so now interfaces were not there in JavaScript, so this is something new, or making it more class-based OOP. However, JS was okay. So now So this feature, okay. Now if you provide an object that doesn't match the interface, TypeScript will warn you. Now let us see a little bit more in detail about how this warning system works in TypeScript. Okay, so okay, let's come here. Now let's see something called as a linter, right? Now what is the job of a linter? Now, first let's understand what does linter mean. Like, what is the synonym in English? Like, what is linter meaning? So, linter is basically a machine that removes short fibers from cotton seeds after. Uh, so basically, oh yeah, linter is basically something called as lint removal, right? Oh, I guess what is I'm trying to say. So when you wash clothes, like in a machine, or when you put clothes in a dryer, right? So at times, what is going to happen is fibers will be present on the clothes, right? To remove that lint or to remove that fiber, we use something called as a linter. So linter is basically to remove fibers. Linter is basically to remove something. You can say that way, or to detect that there was something. Now in programming or in coding, the job of the linter is basically to check for errors, and then it kind of provides us with it kind of checks static typing, static analyzer, and then it performs code analyzer whether there are any logical issues in our code validator and syntax checker. So this is code validator and then syntax. Now when we say to check for error, we are talking about this is all compile time, right? So there is nothing runtime. So we are talking about compile time errors here. We should keep that in mind. Now, similarly as here you have removing some fibers. So here basically you are checking for compile time errors and then you are trying to basically produce them or highlight them when you when you have a compile time error. For example, when you do when you are performing type, you are giving it a specific type and then you, for example, you mention a string and then put in a int. I mean that can be converted, but then suppose if you are having a int and you have an alphanumeric string, right? So that won't work. Then it will try to give you this curly squiggle or wavy thing around the code saying that this is an issue, right? So you need to take care of this. Similarly, basically, like the word linter comes from the thing which is basically nothing but lint removal, right? So this basically happens in clothes when you dry them using a dryer. You get lint, right, on or fabric on the surface of the cloth. To remove that, you use a linter, basically a roll or something else that will take the lint out. Similarly, here it is basically used to detect static errors. That means when you mention a type and then you when for suppose for example you mention a type and then assign it to an incompatible type, then you will get an error. Otherwise, basically uses a code analyzer basically to analyze the code validator, syntax checking, and to check for compile time errors. Let's get back to TypeScript documentation here. So now, if you provide an object that doesn't match the interface, the TypeScript will warn you. So here it's going to warn me. See this, the warning has come over here. See, you see this squiggly line saying that object literal may only specify known properties and username. This is happening at compile time, remember. So this job of giving error is basically something called as uh, is done by a linter, right? Does TypeScript make use of a linter? No. So basically, inherently, TypeScript what will do is it will kind of TypeScript does not use any linter mechanism. Instead, it's the TypeScript itself that is giving you errors related to type issues. For example, type correctness or yeah. So basically, it will give error mostly related to type errors when you have TypeScript, and this will check your code formatting as well. If it's some you're missing some parentheses or some issues, it will give you an error. Or if the code is not formatted well or not auto indented, it will kind to indent the code properly so that it will make it more readable, legible. However, TypeScript will only give you type errors the moment you have an issue with type. So TypeScript will only give you type based errors. For example, you try to assign an interface or something, or your exam you assign a string, you assign an integer to an alphanumeric string which cannot be implicitly converted. So then again, TypeScript will give you an error for those things. Okay. Now, so let's see how to let's see how to get a. So let's try installing TypeScript. So let's see. Let's see. Yes. Okay. Let's open our Visual Studio. Okay. Let's close this or let's get rid of this folder first. So let's we don't need this folder right now. No. So what you can do is you can go to file and then open folder and you can go to let's open this and then let's say new file. Let's have it as a text file and then let's get terminal and then we'll save it. Let's this be a so we are going to save it as script. Okay, so this is my JavaScript file, but we are not going to write code in JavaScript, right? So we need to install TypeScript. So for that, so Node is locally installed in my PC. So let's go back to Chrome and let's see the repository. So for installing the latest stable version, you just need to write this command, basically npm install dtypescript. So let's copy this. Okay, let's have it pasted. Let's paste it, and then so now, yeah, so we have created a new model folder. A TypeScript has come in, and then we have so read package.json. So here you'll see TypeScript, Microsoft, compiler like JavaScript. So basically these are keywords for which you can search. And let's see this file. So basically it is TypeScript, author is Microsoft Corporation, as I said, developed and maintained by Microsoft. The repository link is present over here. License is MIT or Apache 2.0. Version is 5.0.2. So the home page can be visited here. And then so these are basically the dependencies that we need to run for this, for TypeScript to run. So it has something called as ESLint coming in. So linter is already present here, and then you have script. So basically, for example, if you need to build, you just need to do npm run, and then you can build it. Then you have, okay, what is the package manager? Basically this is that git head token, so this is not what we want. And then what else? These are all the dependencies that we need to run TypeScript. Then okay, so let's now go to readme. So readme is like for latest table. Okay, this is how we did. There are many contributors, so it's an open source project by Microsoft, so you can, so for, okay, now we don't want that. Okay. So basically it's taking, this is about security policies which you don't need now. So we have got the node modules. Now dependencies are here. So we have got this TypeScript 5.8.2. This is basically locking our dependencies so that when we run it, there is no issue with that. So now we have already got our TypeScript installed, and then okay, now do we need to have that directory structure, or can we? So now what we are going to do is basically run our, we already have, so we will be writing code in TypeScript, right? So this is not what we want, so we can rename this file to something called script dot, instead of having JS, now we'll do it in TypeScript. So let's, this is tsc, and then let's create a variable. This is and then let's give it int, and then let's make it 10. So now what is happening here is type annotations can be used only in TypeScript files, but I have installed, but this is tsc, right? Let's see what's happening here. Okay, this is the npm. Okay, and then how he has written the first code. So if you go, there should be okay, let's go to roadmap. There will be no place where this is how you can write. So basically this is my TypeScript background, right? So basically this is getting converted to your, this is the conversion that's happening, which we don't want. Okay, Okay. We have installed Node.js, we have got npm, we have installed TypeScript. Okay, the file is .ts, so we can, when we go here, just rename this to, instead of having it at ts, it's, yeah, now it's perfect. So cannot find name, it will see. And then so remember, this is going to be interpreted and compiled, right? So okay, let's see the first example that is mentioned in the docs itself. So if you go here, okay, so he said, no, where was, so this is how he said, right? No, so it will be let's say we are giving this type. Let's say we have this string thing mentioned, right? So let's go here. Let's say that message, and let this be my string, and then say this is hello world. Now, since it is types, the first thing you have to do is you have to compile TypeScript, right? The moment you compile it, you will get a tsc, and then okay, let's say this is no, yeah. So the command tsc is not found. Why? Uh, She's saying command not found. Why? Are we in the same package where it is installed? Looks like some package issue maybe. We have installed it here, right? Inside this. Oh, this is outside. So what we need to do is let's have, okay, yeah, I got what's the issue. Let's get rid of the packages as well. And let's get rid of this. Let's create a new folder, and no, I don't want this. So in this root level, let's create a folder called as TypeScript, and you open this folder, and then now in this you install all the dependencies. Okay, so let's have the node models being present. Have the models come outside. Now it's inside this folder, right? Let's get this as a, so now if you see my TypeScript folder, I have Node.js and this, both of them being installed. Now I need to create something called as an app that are TypeScript file, right? So basically at the root level, root level, at the root, okay, let's add a file called as this is now my TypeScript file is here, and now okay, now I need to move to that, right? I'm in 100, so I'm going to do in cd. Let's try this. Let's go to this folder. Now here I am, and then now let's try compiling our, you can, the moment I write this, It's still saying command not found. Why? I've come in the proper folder as well. There's nothing. Hmm. Why is talking about app dot? Does the dependency mention anything about app not JS? Hmm. So it's why is that come here at this level? Can run TS file is present. I mean, let's see. Now let's see whether that works. Oh yeah, now we got the apps.js file, right? This path was not linked properly somewhere. Oh, it's this is we don't source control, right? No, there was some issue with the path which we were trying to set. Uh, Now let's see the path where we have that using unknown command. Unknown command using. Now if I go to package.log, okay, so it's present in the bin slash this tsc. Now we need to, okay, so this is my bin, right? Oh, this is my tsc. Okay, and then this is my server as well. So I have to create it here. Mm, yeah, so tsc compiler is available here. Okay. Do I have a config file? Like, uh, so what he's saying is you should not put the TypeScript file here. Instead, you should create another subfolder called as src and then link that src to the compiler. So yeah, we need to add our in the root directory level. So if it's not, so this is my node, right? So I need to add it to the root directory. So root directory is yeah, so I need to add in. Okay, we can place the TypeScript files in the root directory if you do not create a separate folder called as src dot and then if you need to compile all the TypeScript files in the current directory or subdirectories, then we need to use npx tsc. Okay. Yeah, so let's see something new. Okay, so once you have the npm TypeScript package in your so let's have the so once I have TypeScript installed, or when we have the package downloaded, now then first thing we need to run, right? So either we can create a tsconfig file and then mention the folder where we want to compile ts files to js. The other way is if we don't use src, then we can use root directories or root slash subdirectories to run to compile tsc, right? For that we need to use npx and then our file name. So what is the without the need to install them globally, you can yeah, so basically this is present in this binary file, right? So we need this to run from the binary file. Here is when our tsc compiler is present, right? And then yeah, so what we are doing is when we do npx, so without doing it's like a global installation, you're just running it within this subdirectory. So npx basically avoids that okay. Or if you don't have npx, then we need to manually navigate to the bin. I can provide the full path. For example, now if here, yeah, so I need to mention this full path. And then now my here is not my app.ts, right? I have to get rid of this and then mention script. So even this is going to work if we don't do the global installation. Or what we can do is we can create a config file, and then we can directly say to our tsc compiler that go to that file and run it. So we are basically saying, okay, in my tsconfig file, I can mention that just go to that specific folder and run all that. So my tsconfig file looks something like, okay, if I manually want to run, this is like a command, right? So it does not install the bin or the compiler globally, but it kind of links my file. It kind of searches for ts file in root and subdirectories. That is how npx is designed. But then if you don't want to use that, so if you want to manually link the compiler, the command to do that would be, you kind of, so compilation file will be compilation, or the compiler will be compiler is present in .bin, right? So we have to navigate to, okay, so navigate to .bin folder, and then we can run our TypeScript code. The other way is basically you mention all of this information in a config file. Or a configuration file. So instead of manually writing it, we would already check this config file, and whatever is path or whatever things have been mentioned in the config file, it will run according to the file itself. Okay. And this okay. So basically, so in other languages like Java C, or sorry, in hello, did you open your AirPods? Hello, hello, hello. So basically, in other language like Java C, like in Java, this is basically how the Java compiler, Java C can automatically locate and compile files. Basically, how the JDK uses its tool and work combined with certain conventions paths, and how command line options that Java uses, right? So even in Java, you have to indicate like to the Java compiler which file to. So Java compiler will be present in a separate folder, right? So you need to get that Java C or Java compiler out. But then the advantage is because of how Java paths are defined, it automatically will search for um, automatically searches for the Java file without the need for us to take care of the path, because there is something called as class path. That is how uh, it cannot. It's so the location and running will have or will occur automatically without the need for us to specify the exact path. However, in other files, we would have to mention the exact path, right? But then the way because Java is developed, there is no need for us to mention that exact path. It will happen automatically. So yeah, so this linking is happening automatically, so we don't need to worry about. So in Java C, the way the compiler is designed, so we do not need to worry much. However, if you're using TypeScript, you need to specifically mention the file, right, and where you have installed the dependency, where is the compiler present, is in which file, and then how to navigate from the compiler file, so that you can get the compiler and then run it locally. This is basically how the dependencies are mentioned. Like we don't need to worry about it, and because the linking is happening automatically, right, you don't need to worry of how the linking is going to happen, and it will run automatically. In this is happening going to so this is Java C, or Java has something called as a class path mentioned, which enables that. But then if you are using other languages like TypeScript, you will have to manually locate the compiler, and then you can do that automation as well by mentioning in the tsconfig file. So I guess, yeah, that is all for this session. I'll see you guys in the next one. Till that time, take care. Bye bye.